Hi all, welcome to this presentation. I'm Matt Felicetti. I'm one of the lecturers in the engineering department, and I specialize in computer systems engineering and artificial intelligence. This presentation, I'm going to explain using LiDAR data in machine vision for automated pruning of grapevines. This is a project that was part of the RAMS lab with Dried Fruits Australia. The problem that we were looking at was the winter pruning of grapevines. Traditionally, this is a task that is done manually, where people go down each of the rows of vines and prune the arms and spurs of the cordon, as you can see here, using pruners. And this, as you can imagine, is a very time-consuming and costly task. So what we wanted to do was attach a cutter to a tractor and in real time, move that cutter backwards and forwards to cut the best position and prune the vines, reducing all that manual labor and automating the task as much as possible. So in doing so, originally to get some vision, we looked at camera footage, as you can see here. However, trying to determine the position using camera footage was very difficult because it's very noisy with the tractor moving, the leaves. It's also difficult to tell the difference between the ground and the vine because they're very similarly colored, especially with a lot of the mulch and vines on the ground already. And you also have to deal with lighting conditions and other constraints. So instead of this, we looked at LiDAR. To get an understanding of LiDAR, first we'll look at laser rangefinders. Basically, a laser rangefinder has a laser and a receiver, and the laser sends out a pulse. That pulse will hit some object or surface and then bounce back and be detected by the receiver. So knowing the speed of light and the time taken, we can determine the distance that something is from the laser. So in our case, we use this particular LiDAR, which had an array of 160 times 60, which is 9,600 lasers, providing an image that looked similar to this, or data that looked like this. And if you have a look at this, you can see that these points here in red are a lot closer to us, where these points in yellow are a lot further from us. So this is some object that's a lot closer down in this bottom corner. So with this, we mounted the LiDAR to the tractor, as you can see here where I'm pointing, with the cutter behind it. And the LiDAR sent the data to a small computer and processes that data in real time. So what it did is firstly filtered out the distances that we're only concerned with. So we weren't concerned with the ground, so we filtered all that out, and we're only concerned where the cutter could actually cut. And you can see this in blue here. With this, the cutter can only move so fast, and we need to make sure that we're not cutting too aggressively. We needed to apply a bunch of different averaging algorithms, which I won't cover here, but these are things to consider. The other thing is that, as you can see, the LiDAR and the cutter aren't perfectly aligned, and so we needed to consider the speed of the vehicle. So alongside the LiDAR, we also use GPS to delay the sending of where the position was, depending on the speed of the vehicle. Now, with this, we were able to accurately cut the arms from the cordon and demonstrated that this is a viable solution for pruning grapevines.